Hello, everyone. Welcome to Serverless at Any Scale, New Dataflow Innovations. My name is Shan Kulandevel, Lead Product Manager for Dataflow, our cloud native big data processing and streaming platform. In today's session, I'm going to introduce what Dataflow is for those of you that are not familiar with the product. We'll then spend bulk of our time talking about Dataflow Prime, our latest and greatest product offering that we are going to be launching soon. We'll then do a quick demo so that I can walk you through some of the new capabilities. At any point in time, if you have questions, please use the chat bot. We have a number of Googlers on standby to answer your questions. Before I dive in and talk about Dataflow, I want to first introduce the big data ecosystem on the Google Cloud side and give you a view of where Dataflow fits in the broader ecosystem. What you see here are Google's products, particularly fully managed, serverless, cloud native products that enables the big data and machine learning ecosystem in Google Cloud. On the one end, you have PubSub, which is our globally available, highly scalable, highly reliable messaging platform. Dataflow, as I said, is an Apache Beam based, fully managed, cloud native data processing platform that allows you to integrate, process, and enrich and extract insights from various data sources. BigQuery is our limitless, serverless cloud data warehouse. Looker is our modern BI and embedded analytics platform that allows you to activate insights and data that you're able to gather by using the other products that I talked about. Vertex AI provides you a suite of machine learning capabilities ranging from machine learning training to machine learning predictions to model management to large scale machine learning operations. All of these products are serverless. These products are fully managed, proven at scale, and based on Google technologies that we've been building for many years to support Google's own products like Google Map and Google Search. Those are products. What do customers want to do with these products? More often than not, when I talk to customers, the kind of problems that they want to solve fall into one of these three categories. First, they want to be able to answer questions around what has happened. You want to mine historical data so that you're able to answer questions around what has happened. For example, you may want to answer questions around what was your sales in the last quarter. Maybe you want to answer questions around what was your user satisfaction last month. Similarly, customers want to be able to answer questions around what is happening now. What is user behavior now? What is user sentiment now? What is the status of my supply chain now? What is the status of my IoT devices now? And lastly, customers want to be able to combine their knowledge of historical data, their awareness of what is happening now, so that they're able to predict the future, so that they're able to answer questions around what may happen in the future, be it user behavior, or how users are going to adopt their products, or supply chain, or their inventory, or so on and so forth. Now, what does it mean in practice? This translates to the capability to support a wide variety of use cases in your data architecture, ranging from simple data ingestion, data replication tasks where you're taking data from your SaaS services or your operational platforms and putting it into your analytics store so that you're able to drive analysis on that data. It may be about integrating data from a number of these sources, enriching it, grouping it, and applying additional machine learning based data extraction. And then finally, storing it in your data warehouse so that you're able to drive downstream BI analytics. And then lastly, it's also about using machine learning so that you're able to extract insights from the data and activate downstream systems without having a human in the loop. Now, historically, customers invested a lot in doing being in batch processing. We see more and more customers that want to do stream processing now. But a lot of the interest when I talk to decision makers lies in introducing continuous intelligence into their organization so that they are able to drive more value to their business and to their users. Now, you may be wondering, some of this is possible today, right? A customer, you may be operating an on-premises environment where you may be able to achieve some of this. One of the common patterns that I see when I talk to customers is the fact that customers end up using a number of different technologies that operate in silos to achieve the results. What that means is, one, some of these products are not proven at scale. So customers have challenges when they want to take these from their development environment to production so that they can support business critical use cases. Second, each of these technologies operate in isolation. So customers are not able to integrate workflows across these systems so that they are able to have an end to end workflow, an end to end view, so that they're able to drive more value. And lastly, these technologies in many cases are significantly more expensive, and customers have to are limited by their IT budget and what they're able to do with the budget that is allocated to them. With Dataflow, you now have a single unified platform for both batch and streaming analytics. What that means is there's a single platform using which you can build both your traditional batch ETL pipelines, your data replication pipelines, as well as continuous intelligence pipelines that can now drive further insights. Dataflow is based on Google technologies that have evolved over 10 plus years, which means that it is battle tested at scale and you get to reap the benefits of a mature platform. And lastly, as I said, Dataflow is a streaming first platform. While it has great support for batch, it is a streaming first platform, which means that you're future proof. And as you look at implementing more streaming scenarios, you don't have to go relearn a new product, understand how to operate and manage a different product. This is one of the reasons why industry analysts and others rate Dataflow and broadly Google Cloud as one of the leaders, if not the leader, when it comes to streaming processing. As you can see in the chart on the right side, Forrester did their annual streaming analytics wave report, and Dataflow was ranked a leader. Similarly, on the data warehousing side, BigQuery was ranked a leader in last year's data warehousing report as well. Now, many of you may be wondering, it doesn't matter what an analyst says, what are users like you saying? I have a number of quotes from users of Dataflow here. I'll let you read through them, but there's one quote that particularly stands out and that I'm excited about. This is a technology centric media organization and a very famous one. And one of the challenges that they had was while there was a critical business need to move to streaming, their choice in technologies and the technologies that they had deployed on premises was a limiting factor. And in spite of the business need and business desire, the data teams and the engineering teams were not able to move quickly enough to adopt streaming. However, in the last year, we worked with them to help them adopt Dataflow and move some of their existing batch pipelines and ETL workflows over to Dataflow. Now, the benefit of that is not only were they able to simplify and have a cloud native architecture and a serverless system, all of their new development now has been on streaming. As you can see, their analysis is 40 to 50% of all of new development in streaming, and which is a huge win for their business. They're able to now deliver insights much more quickly to their users. With that, let me switch gears and talk about Dataflow Prime. Dataflow Prime is our, as I said earlier, is our latest and greatest evolution of the Dataflow architecture. It introduces a new serverless architecture that uses compute and state separation with the ability to both horizontally and vertically scale resources so that you're able to get a most efficient platform for your data pipelines. But before I go talk about the architecture and its benefits, I want to call out that Dataflow Prime is still about the core value prop that we talked about earlier. Number one, it's about enabling you to extract real time insights from your data, be it streaming data or batch data, by applying ML. And two, giving you an unified platform for both batch and streaming processing. And lastly, giving you a very mature technology that you can depend on to operate at scale for your mission critical use cases. As I said earlier, Dataflow Prime introduces a new architecture. But it doesn't matter whether it's a new architecture or an old architecture. All that matters is the benefits that you get. We focused on two primary areas with Dataflow Prime. Number one is improving the system efficiency or the platform efficiency so that you're able to run your data pipelines at a lower cost. Number two is improving developer productivity or operator efficiency, as I like to think about it, by giving you new, enhanced, and better tools that allows you to monitor, troubleshoot, and manage your data pipelines at scale. In the next few slides, I'm going to walk through some of these new features, deep dive into those, and explain how some of those work and the benefits that you get from those. But before I go there, let's quantify the benefits that you see. Forrester recently did a study, what they call as the total economic impact study, to understand the value that customers get by adopting Dataflow. As you can see here, their analysis is many customers see a 55% boost in developer productivity because of the simplification they're able to get from the serverless platform and using a unified SDK. Second, many customers, if not most of them, ended up saving 50%, more than 50% in infrastructure costs, specifically for their streaming workloads. And lastly, customers were able to get a return on investment and payback period in less than 6 months. And for those of you that are familiar with the long cycles that are typically associated with B2B enterprise software, where it takes multiple months, if not years, to learn a new technology, deploy, and get it to a scale where you're able to see payback. With Dataflow, given its serverless and fully managed nature, customers were able to see business results in less than 6 months. Now, with that, we've introduced Dataflow Prime. I'm going to switch gears and then talk through some of the new capabilities that we have. The first one is right-fitting. Before I explain what right-fitting is and how it works, let's introduce the problem. The specific problem that right-fitting solves is underutilization. Underutilization happens in data pipelines primarily because no two stage of the pipeline is the same. A typical pipeline, at the very least, has a stage that reads data from your source system and has a stage that writes to a destination system. But most real world pipelines are much more complex than that. In addition to reading and writing data, you have stages that are processing that data. Maybe there's a stage that aggregates data. Maybe there is a stage that groups things or filters things out, and so on and so forth. So you usually end up with a multi-stage pipeline, with each stage having a slightly different resource requirement. And historically, what systems did was provision resources that are spec to support the higher watermark in terms of resource requirements. And the practical result of that is you ended up with underutilization. As you can see in this illustration, stage one requires more resources. So you size the workers or compute workers to support that stage, which means that stage two, which did not have the same resource requirements, ran on the same set of workers, resulting in underutilization. Now, underutilization in itself, while it's a problem, results in cost increase. What it also happens is a lot of developers end up spending many, many hours in hand tuning their pipelines, hand tuning the underlying infrastructure so that they are able to optimize the infrastructure that is provisioned to support their data pipeline. Now, with right fitting, we want to simplify that, remove that complexity from end users, and give a system that is able to automatically adjust and automatically right size the resources that are provisioned. As you can see in this illustration here, stage one is the same, so ran with the same resource requirements. But for stage two, now that the developer is able to specify resource requirements that stage needs, Dataflow is able to use that information to provision right-sized workers, and in this case, workers that are shaped such that you don't need the same amount of resources as the previous stage. The end result of that is both stages now have higher utilization, which results in reduced costs, and developers didn't have to spend many, many hours hand tuning these pipelines. Another example for right fitting is GPU. Now, customers typically use GPU in their data pipelines for image processing or machine learning inferencing use cases. As you can see, as of today, customers need, if they specify that GPUs are needed for their data pipelines, GPU get added to all stages of their pipeline. What this ends up resulting is that only the stage of the pipeline that does machine learning predictions or image processing ends up leveraging the GPU, and all the other stages do not use GPU, which means that you're overpaying for your pipeline. With right fitting, wherein now a developer can go in and annotate the specific stage of the transform as saying it requires GPU, The platform now is able to provision GPU only for the stages of the pipeline that require GPU. Other stages that do not require GPU do not get GPU's provision, which means that you don't pay for those GPU. Now, here is a code snippet which shows how easy it is using the Apache Beam SDK to annotate specific stages of your pipeline with your resource requirements. As you can see, in this case, in one of the pipeline stages, the developer was able to say it requires 4 GB of memory and a specific model of NVIDIA GPU. And in the second case, they were able to say that stage requires 32 gigabytes of memory or 30 gigabytes of memory, and there is no GPU need. What Dataflow is able to do with that information is now provision right size resources to support each stage of that pipeline. Okay, so that's about right fitting. The second capability that complements right fitting is vertical auto scaling. Many of you should be familiar with auto scaling. And typically, when systems say they do auto scaling, they mean horizontal auto scaling, which is when the load on the system increases, you provision similar sized or similar shaped resources to support the increased load. But what happens in reality is the additional resource requirement may be just in one dimension. And often we see this happen with memory. You may have a set of workers that are supporting a pipeline, but because of change in data volume or change in the shape of the data, now you may need more memory to support that pipeline. Now, in traditional systems, you provision additional workers, which is what horizontal auto scaling is. And when that happens, of course, you're getting more memory, but it also means that you provision more CPU, more disk resources, and more networking resources. And even though you're not utilizing it, you're paying for it. Now, vertical auto scaling, what we are able to do is dynamically resize the workers without having to horizontally auto scale. Again, let me repeat. Without having to horizontally autoscale and provision more resources, the system is able to dynamically resize the workers so that there is more memory available. In this specific example, more memory is available to the pipeline. What you have now done is you've detected that, or the system has detected that there's memory pressure and the pipeline would benefit from more memory to avoid things like out of memory errors. And without having to provision additional nodes, has just resized the workers so that there is more memory available. And the end result of that is one, reduced out of memory errors, and two, reduced resource wastage because you haven't provisioned additional resources just to address the memory problem. Here is a monitoring graph that shows for a real world pipeline how vertical auto scaling kicks in and provisions additional amount of memory. And as you can see, as the data volume increases, as the need for memory increases, vertical auto scaling is able to kick in and provision additional resources. Now, we talked about right fitting and vertical auto scaling, which are two techniques that are going to significantly help customers optimize their pipelines and get the maximum out of the system. The next two capabilities that I'm going to talk about are user centric. These provide new capabilities for developers, for operators, for the users that are monitoring and troubleshooting the pipelines so that they're able to much more efficiently debug and manage their pipelines. The first one is a capability called data pipelines. Data pipelines provides a new interface and a new abstraction to manage pipelines at scale. You can set schedules, you can set up recurring jobs, and you can easily understand and reason about your jobs, specifically recurring bad jobs, using a new abstraction called data pipelines. The second capability, which I want to show when we get to the demo, is job visualizers, which provides a UI centric, a visual manner for you to inspect your data pipelines, understand what's happening with your data pipelines, identify bottlenecks, and so on and so forth. With that, let me transition over to the demo and walk you through some of the capabilities in the UI. Okay, I'm now switched into my Google Cloud Platform console, and I'm in the landing page. Let's go ahead and navigate to the data flow section of the Cloud Console. I'm now in the data flow section, and as you can see on the left nav, I have my jobs, snapshot, my notebooks, which are called Workbench now. We've got the new data pipelines capability, and then the SQL workspace. Let's go ahead and first navigate to the pipelines section. This is the new data pipelines capability that I talked about, which allows you to create data pipelines and manage them at scale. I can go ahead and very easily create a data pipeline here. Let's say test. I'll be able to select a data flow template that I want to use. I'll be able to specify any other options that I need to specify for that data pipeline and go ahead and run that job. If I were to do that, it'll get automatically deployed as a data pipeline. In the interest of time, let's go to one of the data pipelines that I had created earlier. Let's pick one. And as you can see, this specific pipeline has been running for 71 days, and it has run for a little over 1700 times. Let's go into the details page for that pipeline and look at what I get to see. As you can see, I have a view of all the historical executions of that pipeline. I also get a visual graph for me to look at the elapsed time or wall time of each of these executions. So I can easily pick out any outliers or any time the job either ran fast or too slow, so that I can identify outliers and easily troubleshoot that. I also have a lot of information about the pipeline and the template that was used for it available right here. I can go into the pipeline metrics section, and then I can find detailed metrics about the job. Again, over time. If I go into the SLO tab, I can now monitor SLOs that I care about. I can go ahead and set alerts so that if the SLOs are not met, I get automatically alerted. Let's go back to the pipelines UI. As I was saying, this is the place where I get to see all of the data pipelines that I've created. I don't see each and every individual job. For that, I can dig into the details of a specific pipeline, and I get a summary metrics of all of the data pipelines that I currently have operational. Let's navigate to the jobs section of the UI so that we can take a look at the new job visualizers capability that we introduced. Let's first start with the batch job. I've selected a job. You should be familiar with job graph section of the UI, which has been available. The new capability that is available now is the execution details section of the UI. If I go in there, I have multiple different views in which I can view and inspect the job. The first one is the stage progress, which gives me the list of fused stages of the job, and I'll be able to look at the execution time over various stages. I can look at the workflow, which is basically the fused version of the job graph, so I can actually look at what gets executed. I can also look at the progress in terms of the workers that are contributing to that job. As you can see, in this case, there are two workers that were used at various points in time. Let's go back and see how the job visualizer UI looks for a streaming job. Um, in this case, I've selected a streaming job. As you would expect, the experience for streaming jobs is slightly different from that of bad job. I still have stage progress and stage workflow, but in stage progress, I have this chart that shows me data freshness. And you can see in some cases, the system is automatically flagging potential slowness based on spikes in data freshness. I'll be able to select that, and then I can look at the progress of my stages, and then easily troubleshoot what may be contributing to the slowness. And for each of those, I can, if I were to select a specific stage, you can also show you can also see specific steps in the stage and the wall time for each of those stages, so that you can clearly understand what specific step may be contributing to the slowness. With that, let's quickly summarize. We walked through two new capabilities in the user experience. One is called data pipelines, which allows you to create data pipelines and manage jobs at scale. The other capability is job visualizer or execution details, which gives you a much more in-depth view of your data pipelines. With that, we are at the top of the scheduled time. Thank you very much for taking the time and joining us today. We are very excited to get the product in your hands and get your feedback. If you have any questions, please add those questions to the chatbot. The team and I are happy to answer your questions. Thank you.